Hey you guys, sorry I'm not there. Home with a kid with a fever. So this is for 6A and it's relations and functions. We're going to talk through the details you need to know about it. You do need to take notes on this. I'm going to check your notes and give you credit for them. So if you don't have these filled in on Monday, you'll get a 0 out of 5. So make sure that you're taking these notes, fill in what I fill in so that I know that you heard the lesson, okay? So formalizing relations and functions. We're going to talk about domain and range. So starting with domain, okay, that's the input numbers. It's the numbers that you're going to put into a function. Typically, this is your x values are your domain. And then the range are the output numbers. And those are typically the y values. They don't have to be x and y, but for what we're going to do, they will always be x and y. So that's domain and range. And then relation is just putting those two things together. So it'll look like this. You'll have an x and a y, and you've seen that before. That's a point, right? So it's naming a point on a coordinate plane, essentially. So what we're going to do today are two different things. You're going to do what are called mapping diagrams, and you're going to do the vertical line test, okay? Mapping diagrams look like this. You will have a box and another box. And what you'll do is you'll take all of your x values and put them in this box, and you'll put your y values in this box. But the thing to remember, two things. We want no duplicates. So if my list of points, relations, has 3 different x values, and they are 1, 1, and 3, you would only write 1 and 3. Even though there's 2 1s, we don't write it twice, okay? Same goes for the y. No duplicates for your y's. So I don't know if that goes away when you see that. Sorry, we'll leave that there. 1 and 3. So you cannot have any duplicates, and then we always put them in order. So from least to greatest, like I did 1 and 3 there. So say 2, 4, and 5 are our y values. That would come if we had this set up. So say we had the point 1, 4, the point 3, 2, and the point 1, 5. Okay, if those were our points, notice what happens here. We have 2 1s and a 3. 1 and 3. Then we have a 4, a 2, and a 5. We put them in order, 2, 4, and 5. Okay, now here's how a mapping diagram works. When you draw the line in to connect them, it helps you to see if something is a function or if it's not. So 1, 4, we go from 1 to 4, and we draw that line in. 3, 2, we go from 3 to 2 and draw that line in. And then 1, 5, we go from 1 to 5 and draw that line in. Here's how you tell if it's a function. If any of your x values have 2 lines or more coming off of them, like the 1 does right here, that makes it not a function. Okay, now you can have 2 going to the same y value, but you cannot have 2 coming off of the same x value. Let me show you what I mean by that. Let's say you had a mapping diagram that looks like this. We have -3, 0, 4, and 1, 2. Okay, I can have a mapping diagram that looks like this. So 4, 2, 0, 1, and -3, 1. Notice there's 2 y values here, or 1 y value that has 2 lines going to it. This is a function. We would say, yes, this is a function. This one over here, however, this one's not a function because the x value has 2 lines coming off of it. Okay, so that's how you're going to tell if something is a function. So let's look at example 1 here. It says identify the domain and range of each relation and then represent it with a mapping diagram And is it a function? Okay, so the first thing we need to do is set up domain and then range. Okay, so let's look at domain. We said domain was the x values. So if you look at this problem, you have a -2 for an x, you have 0, you have 4, and you have 5. There are no duplicates, so you're going to name every one of those, and they're already in order for you. So you don't have to rearrange anything, you just write them out. -2, 0, 4, and 5. Okay, and then you put the little brackets around it. Okay, for the range, let's use a different color here. The range is your y values. So that's going to be 0.5, 2.5, 6.5, and 2.5. Now notice what happens there. We have two 2.5s. You're just going to write it once. So in order, no duplicates. So our smallest one is 0.5. Our next one is 2.5. And our biggest one is 6.5. Okay, so that's the first part. Identify the domain and range. Here's your domain, here's your range. Okay, if you need a pause to catch up, just pause me for a minute and then you can start up again if you're still writing. Okay, then it says represent it with a mapping diagram. So the mapping diagram goes like this: a box here and a box here, and then we're going to draw lines in. So this is going to be your x values, this is going to be your y values. And you already put them in order with no duplicates, so you're just going to write them in. -2, 0, 4, and 5. And then here, 0.5, 2.5, oh, messy, and 6.5. Okay, so if we draw those points in, -2.5 is going to be one arrow. 0, 2.5 is the next arrow. 4, 6.5 is your third arrow. And the last one is 5, 2.5. Okay, so that's the mapping diagram. Last thing here is the relation a function? So think about what we said. If your x values don't have multiple arrows coming off of one number, it is a function. Now here, your y value has 2 arrows going to it, but none of your x's have more than one. One here, one here, one here, one here. Okay, so is that a function? We would say yes, this is a function. Okay, so that's what you're going to be doing with mapping diagrams. Let's do one more of those. Okay, so domain and range. The domain, that's your x values. So you have 6, 4, 6, 5. Okay, now notice right away you can see there's 2 6s, which means you have 2 of the same x, which means you're going to have 2 arrows coming off of 6, which makes it not a function. So technically you can tell right now that it's not a function, but we still need to put the domain. So in order with no duplicates would be 4, 5, 6. Okay, then your range, look at your range here, 5, 3, 4, and 8. So in order with no duplicates is 3, 4, 5, and 8. Okay, then we make our mapping diagram. So the 2 boxes, you have your x's and your y's. Your x's are 4, 5, and 6. Your y's are 3, 4, 5, and 8. And then you look at your points to connect. So 6 connects to 5, 4 connects to 3, 6 connects to 4, and 5 connects to 8. Okay, notice right here, we have 2 lines coming off of the 6, so is this a function? We would say no, this is not a function. Okay, you cannot have two x value or one x value with multiple y values. Wouldn't work. Okay, so that's mapping diagrams. Second part is the vertical line test. And this one's really simple. Basically what you're doing here is you're looking at a bunch of points, and once all the points are plotted, if your vertical line, okay, if it hits 2 points or more at one time when drawing a line vertically, then it is not a function. So what you're going to do, and let's just show you right here. -4, 2. 1, 2, 3, 4, 2 is right there. -3, 1 is right there. 0, -2 is there. -4, 1, 2, 3, 4, -1 is there. And then 1, 2. Okay, so we have all these points, and they're asking, is it a function? Well, here's what you're looking for. If you have somewhere that you can draw a vertical line, and it's going to go through 2 points. So remember, vertical is this way, up and down, right? So if you look right here, if I draw a vertical line there, I hit 2 of my points. That can't happen. So if you hit 2 points going vertically anywhere on the graph, then that is not a function. Okay, if you need graph paper today, there's graph paper up behind my desk there in that little tray. You're welcome to help yourself to that. Okay, so that one we know is not a function. This next one, we don't have points, we have an equation. So what you need to do is you need to set up a t-chart so we can figure out what some of our points are so we can see what this graph does. Okay, so you have x, you have y. Let's just plot some points. So this is a good one to do our -2, -1, 0, 1, and 2 on. If we plug in -2, this one's a little bit tricky with how we work it out. This is the opposite of -2 squared plus 3. Okay, this part, -2 squared, is a +4, right? -2 times -2 is 4, but there's a negative out in front of that. So this is -4 plus 3, and -4 plus 3 is -1. Okay, then we do it with -1. The opposite of -1 squared plus 3. So -1 squared is 1. The opposite of that is -1. -1 plus 3 is 2. Okay, and then we plug in 0. The opposite of 0 is 0. There's no opposite there. So 0 plus 3 is 3. Okay, then plug in 1, and this is going to work out, if you remember, it's a parabola, right? Whenever there's a squared, it's that U shape. So the opposite of 1 squared is -1 plus 3 is 2. So just notice it jumps back again. And then plug in 2. The opposite of 2 squared is -4 plus 3 is -1. That's how parabolas always work. Okay, so if we plot these, you have -2, -1 right here. -1, 2 right here. 0, 3, 1, 2, and 2, -1. Okay, that means our graph looks like this. Okay, if we try to draw a vertical line in with the points that we have here, okay, we hit 1 there, we hit 1 there, we hit 1 there, 1 there, 1 there. A parabola is constantly moving outward still, so it's never going to hit 2 points at the same time vertically. So we would say, yes, this is a function. Okay, so that is your lesson for today. You are doing mapping diagrams and the vertical line test, and that is it. If you have questions on any of it, feel free to ask one of your neighbors who maybe has a better understanding right now. And then I will, of course, go over it with you on Monday as well. Have a good weekend.